Welcome to another integral. Okay, this is integral is looking hard, but believe in yourself and believe in algebra. Okay, let's start. Let's find the derivative by a, and a and b is constant, so let's find the derivative by a. Okay, the derivative of a and b and the dz of dA is equal to, if we derive by a, we got integral from 0 to infinity of that e in minus ax times sine of bx squared here by x, and minus because the derivative of that is minus x dx. Now, because we want to cancel this, we can derivative by b. Let's do it. Let's call this integral g of b. Okay, g of b divided by gb squared, so integral gb by b is equal to integral between 0 to infinity e in minus ax times integral of the derivative of that is times 2 sine bx times the derivative of sine. The derivative of sine is cosine bx times the derivative of this is x, so x and x cancel out, and here we got minus because the derivative of that. Okay, now we got this integral, this is sine 2bx. Okay, so now let's do integration by part. This one we worked minus e in minus ax, and here we can work that sine 2bx, and let the derivative, find the derivative of that is a times e in minus ax. The derivative of that cosine 2bx times 1 over 2b. Another level, if we derivative of that is minus a squared times e in minus ax. Okay, the derivative of that, the integral of that, the derivative of cosine is minus sine, so the integral is plus sine. Yes. Just a second. Here we need minus because the derivative of sine is cosine, so the integral of sine is minus cosine. Okay, so the integral of cosine is plus sine, so minus 2bx times 1 by 4b squared. So now from here, if we put this in g of b, if we put this in k, okay, this is k is equal to that e minus x times that minus is plus 1 by 2b times cosine 2bx. So for now minus, because this now minus e in minus x we got here, and now a divided by 4b squared times that sine 2bx. Sine 2bx Yes. Now that's this plus, minus, and plus. Let's see. No, this minus, minus is plus. Okay, this here plus. Oh, now here. This minus, minus, plus. This plus. So here plus. Integral from 0 to infinity. Yes. Of plus a squared by this, a squared by 4b squared times this in minus ax times sine of 2bx dx. Okay, so we can see that this and this is same thing. So let's move it to another side. This is k, minus k, because minus a. Okay, let's move k, this minus, so if we move it plus a squared by 4b squared k is equal to e in minus x times that cosine 2bx divided by 2b plus a divided by 4b squared times sine 2bx. So now we can move it to here divided by 1 plus this, the constant of k. So let's move it for other side, 1 plus a squared divided by 4b squared. So k is equal to that. Okay, so let's plug in 0 to infinity, of course. If we put the infinity 0 because in minus infinity is 0. So if we put 0, this 1, this 0, and this is 1 by 2b. Okay, yes, 1 by 2b. So is equal to 0 minus 1 by 2b times that, because it's 0, sin 0 is 0, that if we multiply by 4b squared other side, we can get to 4b squared by 4b squared plus a squared, okay, and this and that cancel out. Here we got 2 and here we got b. Yes. So now we got this. So we want this. What we can do? Let's do the integral by b. If we put in b 0, we got 0. If we put 1, we got our integral. So let's do integral from 0 to 1 of d of a b d b is equal to, this is minus. Okay, if this is minus 2b divided by 2b squared plus a squared, this is natural log. Okay, between 0 to 1 I forget what. Okay, if we can work it like I of 1 minus I of 0. This is part is 0, this I of 1 is our integral, So minus natural log of sorry, here we got 4 natural log of 4b squared plus a squared times the derivative of that is if we derivative it, so the derivative is 1 by this times the derivative of that 8b, we got 2b. So let's, if we multiply by 4 and 4, this 8b, and by 1 by 4, multiply 1 by 4. Okay, this is integral, and let's plug in 1 and 0. If we plug in 0, if we plug in 1, we get minus natural log of absolute value 4 plus a squared, okay, times 1 by 4. If we put 0, we get minus natural log of absolute value a squared times 1 by 4. Okay, this is what we get. This is, now we need integrate another time because that, but from here we need the integral by a. Okay, so from here, if we a is infinity, we got 0. Okay, let's do integral between 1 to infinity of this I of 1 of I of 1 dA. Okay, so this is integral from this 1 to infinity, that minus that. So this is plus, because minus that minus is plus. Okay, so 1 by 4 natural log of a, and a, this 2 is over here to here, minus that. Okay, 1 by 4 natural log of 4 plus a squared. We not need natural log because this is positive. Okay, now this part we know, this integral of natural log of a, this a natural log of a minus a, and this part, what is this part? Okay, let's do integration by parts, because the derivative of that squared is 1 by a plus a squared times the derivative is 2a, and we can work it here. 1 by 4 is the derivative, the integral 1 by 4 times a. Okay, let's work it. I of infinity minus I of 1. This is 0. Okay, and now we can get 1/2 times a ln a minus a. This is the integral of the natural log, minus minus of that. Okay, 1 by 4 a times natural log of 4 plus a squared. No, plus minus the integral of that. Okay, minus integral 1 to infinity of that. 2 and 4 cancel out. Here we got 1/2 a squared by a squared plus 4 dA. If we plus 4 and minus 4 here, we got a squared plus 4 divided by same thing is 1. Okay, so minus I1 is equal to half a natural log of a minus a by 2 minus this guy, a natural log of a squared plus 4 by 4, because it's okay, and that minus 1/2 times 1 is, the integral is 1/2 times a, okay, and sorry, it's not 1, is not minus, because we got minus is plus, and now we got minus and minus, 3 times minus is minus. Okay, so from here we got minus 4 by a squared plus 4. This is 4 natural a, this is plus arctangent minus 1 of a by 2, because 4 is 2 by in power 2 times 1 by 2. Okay, so this is our integral. Let's plug in. Plug in 1 and infinity. Okay, if we plug in, let's do something. I1 is equal to this, that, and that. We can work this like here. Let's multiply by 2 here and here, and let's move a here, and a by 4 times natural log of a squared by that, a squared plus 4. Okay, so this is this cancel out, minus 4 that. 4 by 2 is 2, sorry. 4 by half. 4 multiply 1 by 2. Okay, this is 2. So arctangent minus 1 of a by 2. All this, all this 1 to infinity. We need plug in. If we plug infinity, we got here 0, because a squared by a squared in infinity is 1. Natural log of 1 is 0. So we got minus I1 is 0 minus 2 times arctangent infinity is 2 times pi over 2. 2 times pi over 2. Okay, this is pi. Okay, let's plug in 1. This is minus 1 by 4 natural log of 1 by 5, because 1 by 5. Okay, minus 2 times natural arctangent minus 1 of 1 by 2. Okay. So there is something wrong here, because from here we got half times 1. This is this part. Okay, I'm talking for this. This is 1 minus 4 times by a squared by 4. Okay, half times 1 is half a. Okay, minus is minus 1/2, this is here, times integral, the integral of that. The integral of that is r by 4 here, and the integral of 1 by a squared plus 4 is arctangent a by 2 times another 1/2. So here we got 1/2, 1/2, and 4. All these things cancel out. Yes. So from here we cannot have 2. Not have 2. Okay, let's plug in again. Let's plug in again. Infinity is 0. Let's plug in infinity is pi by 2. Okay, because rectangle infinity is minus pi by 2. And if we plug in 1, so 1 by 4 is 1 by 4 times natural log of 1 by 5. Okay, and 1 here is no 2 here. Arctangent 1/2. Okay, so the answer, don't forget that minus. Okay, if we multiply by minus, so pi by 2, this plus times that. Minus here, because we multiply by minus 1. Okay, this natural log of 1 by 5, but it can work with 5 by 4, and here we use minus, and minus arctangents of my 1 by 2, with this is equal to f0.704 789. Okay, this is the answer.